Okay, everybody, we're going to work on one of the questions in section 2.1. These questions are randomized in the order. So right now I'm doing question 4, but when you attempt this, you may find that it's question 3 or question 1 or whatever. So don't worry about the question number. But I'd like to go ahead and go through this. So we're just doing a frequency table and a histogram on this one. So you can see it says below are weights of mollusks randomly gathered on the coast of Southern California. I think there are, let's see, 5 times 8. So there's 40 values here in the table. And it says to make a frequency table using 8 classes. And so I'll just go ahead and what I've got is I've copied this over to a document that I can write on. So let me just pop over there. Okay, so I've copied this over. All of these values are to the nearest tenth. And so when I do my computations, everything I'm going to do is going to be to the nearest tenth and rounded one way or another. So let's go ahead and jump on in. So the first thing you do is compute the range. So you can see down here the range is the maximum value minus the minimum value. These values will be sorted from low to high. So the first one here is the min and the, oops, darn it. Sorry about that. First one up here is the min and the last one's the max there. So we can just start with the computations. Max minus min, that's 13.3 minus 0.5. And of course, that's 12.8. Okay, so that's the range. And then the class width, you just take the range and you divide by the number of classes. So you can see the range is 12.8. And we're dividing, it says 8 classes, so we'll divide this by 8. And when you run that, you'll get 1.6. And it's exactly 1.6. Okay, regardless of what you get here, you want to round this up to a larger number. So I'm going to make this 1.7. It always needs to be made larger. Okay, so I've got a little note here that I'm going to uncover right there. So it says make the class width larger, always larger, and then round to the same number of places as the data. So the data values up here are at the nearest tenth. Okay, which means that the class width has to be out to the tenths place, but you don't round it with a normal rule. You make this larger. So whatever this digit is in the tenths place, go up to the next digit. Okay, so 6 goes up to 7 and whatever. Okay, so that's that. Now, to make the table, you're going to start with the min, which, as you can see up above, it's 0.5. Okay, and then from there, we're going to add the class width. So we're going to add the 1.7. Okay, so 0.5 plus 1.7 is 2.2. And then do it again. You just keep adding 1.7. So here you'll get a 3.9. And you just continue. So 3.9, then a 5.6, then a 7.3, then 9.0, then 10.7, then 12.4, like that. Okay, now, we now need, those are the lower limits for the classes. Now we need upper limits. And so what you want to do is just look at the lower limit from the second class. It's 2.2. Think of it as 22. You have to go down by 1 on this. So you're 22, if you go down by 1, it's going to be 21. But instead of 22 and 21, it's going to be 2.2 and 2.1. So the upper limit of the first class has to be a 2.1. These classes can't overlap. And then from the 2.1, once again, you're going to add 1.7. Okay, and just go through it. So 2.1 plus 1.7 is 3.8. And then you add it again. Okay, and so I'll just put the rest of these in here. 2.1, 3.8, then 5.5, 7.2, 8.9, 10.6, 12.3. And again, one more time, you add 1.7 and you get 14.0. Okay, and all together, that makes 8 classes. All right, now I'm going to erase all these notes that I added just to clean this up. Okay, so those are the classes. And then the next thing you do is you want to tally this up. So in the first group, the first class, I need to count how many values are between 0.5 and 2.1. And it's just these 2 values, which I've circled. So I'll just, on my tally, I'll do 2 tally marks here. The next group is 2.2 to 3.8, so that's going to be these. There are 3 values in that range, so we'll do 3 tally marks. Okay. Next, we're doing 3.9 to 5.5. So 3.9 to 5.5, these are the values. So let me try that again. All right, so it looks like there's 8 of those. Sorry, it's 3.9 to 5.5. Looks like there's 7 of those. Okay, so 1, 2, 3, 4, 5, 6, 7, like that. Okay, next. It's 5.6 to 7.2. All of these and all of these. So that looks like 8 values. And I think I did it wrong again. Not a very good counter. 5.6 to 7.2. So there's 4 and 3. So no, it's 7. Like that. Now I have to count 7.3 to 8.9. There's a lot of these. Okay, and that looks like 13 to me. 5 and 8 are 13 values. So here we go. Just barely got that in. Okay, the next group is 9.0 to 10.6. So it looks like is that just one value? That's it, one of them. That's kind of odd. Like that. Okay, and then 10.7 to 12.3. Oops. So let me just see. 10.7 to 12.3. That's all of these. Okay, so 1, 2, 3, 4, 5, 6, it looks like. So I'll tally them up. Okay, and then finally, the last group is 12.4 to 14.0. It's just this last number here, 13.3, falls in that last group, and we'll just do one tally mark. Now the frequencies are just counting the tallies, so there were 2, 3, 7. This should be a 7 here. 13, 1, 6, and 1. That's what I got. And now we want to add all the frequencies up to see what our sample size is. So altogether, the total, if you count, there should be 40 values here. Okay, now that's needed because 40 is the sample size. 40 values in the sample. And just for your information, the sample size is always n. Okay. And the relative frequency, you have to divide the frequencies. So the frequencies are f, sample size is n, and the relative frequency is f over n for every category. So 2 in the first category out of 40 is the first group. 3 out of the 40 values are in the second group. 7 out of 40, and so on. Okay, and then these need to be converted to relative frequencies in decimal. Okay, some of these would be exact, but actually these are all exact, so I'll get rid of those wavy equal signs. So the first group, if you do 2 divided by 40, you get 0.050. No rounding at all here. If I was rounding, I'd use a wavy equal sign. And then a 0.075 for 3 out of 40. And then 7 out of 40 is 0.175. It occurs twice. 13 out of 40 is 0.325. Okay. Then the 1 out of 40, haven't done, so what's that? 0.025. Okay, 6 out of 40 is 0.150. And the last one, 1 out of 40, which we've seen is 0.025. Like that. Okay. Now, the class boundaries, best way to think about the class boundaries is they are averages between an upper limit. Hang on. Okay, so I want to make that bigger. Okay, so the average of an upper limit in one class and the lower limit in the next class. So between the first and second class, we would average the 2.1 and the 2.2. Just add them up and divide by 2. And you get 2.15. That's the boundary between between the first and second classes. Right there. There's a whole bunch of other boundaries. There actually needs to be a boundary before the first class, and then the rest of the boundaries are going to be between all the other classes. So you can notice that in the first class, the upper limit over here was 2.1, and the boundary that goes above that is 2.15. So all you really have to do is just add a 5 to this. So I'm going to look at all of these upper limits and just add 5s at the end of the number, and those are going to be the class boundaries, and you can always do that. So the next boundary is looking at the next upper limit here. You have a 3.8. So the boundary down here would be 3.85. And the next one would be 5.55. Then 7.25. Then 8.95. Then 10.65. then 12.35, and finally 14.05. And remember, the width of each class is the distance from any of these to the next one. So if you add, and our class width was 1.7, so if you add 1.7 to any of these, you'll always get the next one. Okay, and so that's just a fact, all the way down to the last one. I'm saying that because there's another class boundary before the first class that you'll always have to figure out here. And so the easiest way to do that, since we know the second boundary, to get the first boundary, you can just subtract the 1.7. Okay, so 2.5 minus 1.7 is 0.45. So the first one, the first boundary is usually the last one I do, because it's the one that you can't just look at these upper limits. Looking at all these upper limits, if you just add 5s to the end of those make all of the boundaries except for the first boundary here. And to get that first one, we just take the second one and we subtract the class width. Okay, so I hope that makes sense. And we're to the point where there's really nothing else we can do here. It's now time just to enter these values into the homework and then make the graphs. So I'm going to go ahead and do that real quick. This may be all you really needed help on, but I'm going to go ahead and take the rest of this video and just answer all the questions in the homework. So very quickly, I'll pop over to that. Here's the homework. I'm going to zoom in just a little on this and put in some of these numbers that I've worked out. Okay, so I could go ahead and start keying in all these values that we worked on. So we can put in the lower limits. Very quickly, let me see if my keyboard's working. Okay, so the first lower limit was 0.5. Then 2.1 for the upper limit. The frequency was 2. And the relative frequency is 0.050. Next class, the lower limit's 2.2, upper limit 3.8. Frequency was 3, I believe, and the relative frequency 0.075. Okay, next class, lower limit was 3.9, upper limit 5.5. Frequency is 7, and the relative frequency is 0.175. Okay, next class, the lower limit is 5.6. The upper limit's 7.2. Frequency is 7 again, so once again, the relative frequency is 0.175. Next class, lower limit is 7.3. The upper limit is 8.9. The frequency jumps up to 13, and the relative frequency is 0.325. Okay, next class goes from 9.0 to 10.6 with a frequency of just 1. And that's a relative frequency of 0.025. Next class goes from 10.7 to 12.3 with a frequency of 6, kind of odd, and a relative frequency of 0.150. And then the last class goes from 12.4 to 14.0 with a frequency of 1 and a relative frequency of 0.025, I think. Okay, so that's the hardest part of the problem. I'm going to check these answers and get my fingers crossed, make sure, yeah, everything's good here. Okay, then I'll go ahead and put in, it wants the class boundaries now. So the first one we figured out was 0.45, then 2.15, then 3.85, okay, then 5.55, then 7.25, then 8.95, then 10.65, then 12.35, and the last one is 14.05. Okay, and we'll check the answer. Hopefully that's all good. I'm going to double check. Yeah, so all of these got a green check mark, so everything's right. And then we can start drawing our graphs. So the thing I want you to notice is that the class boundaries are actually the, how do I say it? They're the dividers on the horizontal axis on the graph. So if you look at this first class, it goes from 0.45 to 2.15. Those again are the first two class boundaries down here from 0.45 to 2.15. So when you do this by hand on the exam, you want to make sure that you're using those class boundaries down on the horizontal axis. Okay, so I put a bad number in here for the first bar, but the first bar should have gone up to 2, I believe, and the second one to 3. And then 7, and another 7. Then I think the next class goes up to 13. Then a 1, which is kind of a fluke, and then a 6, and then back down to a 1, I think. 161, yeah. So this is a pretty ugly looking graph, and I feel like I'm going to be guessing a little bit about the shape when it asks for the shape. But it does verify that my graph is correct and everything's good here. Now, I could say that's kind of a rough bell shape. I'm not really comfortable saying it's a skewed distribution, so I'm going to say very roughly bell-shaped on this one. And I think that's all I need to answer here. So we're all done on that one. Okay, so check my answer. And let's double check, make sure everything's good here. I'm trying to scroll on my iPad and having trouble. There we go. Okay, so check answer. It looks like I got everything right on this one. So that's it. Best of luck to you guys.